Good morning, Miss E.
Good morning, class. I'm Miss Ian. Today I will be showing you guys two examples of solutions to exponential equations. I believe there are many students are not aware of the differences between equations that involve multiplications, divisions of indices, and addition, subtractions of indices. So today I will be showing you guys the differences between these two types of equations by giving you two examples. Before we can go through the equations, first of all, I will need to go through the rules of indices that we will be using to solve these equations. Okay, so let me write down the rules of indices. Okay, I think everybody should know that the first rule, which is a to the power of m times a to the power of n, and these two indices can be expressed, can be simplified by finding the sum of their power. And when we have a to the power of n, a to the power m over a to the power of n, this can be simplified by finding the difference of their power. And as for a to the power of m and the whole thing to the power of n, this can be simplified by finding the product of their power. And we also know that a to the power of 0 is always equals to 1, regardless what the a value is. Anything to the power of 0 is 1. Okay, so next thing I'm going to show you the first equations in this example 1. As we can see in these equations, it involves the operations that involve between the indices are multiplications and divisions. So when you have equations that involve multiplications and divisions between the indices, what we need to think of is we have to think of a way to combine these two indices as one index if they have the same base. And in this situation, you can see that the left side, both indices has base 5. So the left side, we can actually combine these two as one by adding their power. Whereas for the right side, you can see that there is a different base where the numerator there is 125. So we need to make 125 to be the same base as the rest of the indices. So we have to make 125 as 5 to the power of 3. So as for the left side, okay, let me use white. And as for the left side, we can simplify these indices by adding their power. And as for the right side, 125 has to be expressed as 5 to the power of 3. As we have 125 to the power of x, then we have 5 to the power of 3 to the power of x over 5 to the power of x. For the left side, we can add their power, then we will have 3x plus 2. And as for the right side, since there's a division involved, and the base of these two indices are the same, so we can simplify this by finding the difference of their power, which is 5 to the power 3x minus x. Since we have both sides of the equations simplified as one index with the same base, and these two sides are equal, so for this to be true, the power has to be the same. Then we can equate their power. 3x plus 2 equals to 3x minus x. Then we will have 3x plus 2 equals to 2x. Then we have x equals to negative 2. So this is the idea of solving the equations that involve multiplications and divisions. Multiplication and divisions between the indices. Next, I'm going to show you the equations which involve additions, and subtractions. So you might be thinking to use the same way like how I solved the equation in example 1. You might be thinking to combine these two indices as one, but this is not possible because when the operations between the two indices is minus, we can't really combine them as one. So instead of combining them, what we need to do is we have to break down this power 2x plus 1 and break down this power x plus 1. Okay, so this is the idea when you see addition and subtraction, you have to break down their power. So how am I going to break down the power? Let me show you the rules of indices. So in rule number 1, so when we have a to the power m times a to the power n, we can simplify this by adding their power, which means when we have a to the power of m plus n, we can break down this power and express as a to the power m times a to the power n, which means when we have 5 to the power 2x plus 1, this thing can be broken down as 5 to the power 2x times 5 to the power 1. And when we have 5 to the power of x plus 1, this again can be broken down as 5 to the power of x times 5 to the power of 1. So this is what I am going to do to the equation I show you guys in example 2. Okay, let's go back to example 2. So instead of combining this, okay, I'm going to break down this as 5 to the power of 2x times 5 to the power of 1. And the second index, I will break down this as 5 to the power of x times 5 to the power of 1. And the rest, I will just copy this. So next, what am I going to do is we have to use substitutions. Maybe I let y be equals to 5 to the power of x. If we use the substitutions, you can see that all these 5 to the power of x can be replaced by y. But you might be thinking, what should we do to 5 to the power of 2x? Okay, let me show you this. So as we have 5 to the power of 2x, which is 5 to the power of 2 times x, this can also be expressed as 5 to the power of x to the power of 2. Because 2 times x and x times 2 are the same. So in this index, we can put as y to the power of 2. So we know that we will replace 5 to the power of x by y. So 5 to the power of 2x is actually y squared. So these equations will become y squared times 5 minus y times 5 plus 2 equals to 2 times y. Okay, next we will simplify these equations. And we have 5y squared minus 5y plus 2 equals to 2y. And then we have 5y squared minus 7y plus 2 equals to 0, which is only a quadratic equation that can be solved easily. So I'm going to factorize this. Then we will have 5y minus 2y minus 1 equals to 0. Then we will have y equals to 2 over 5 and y equals to 1. But student, please bear in mind that you do not leave this as your answer, as we are actually solving for x. We are not finding y. So next we still need to continue with this. And we found y equals to 2 over 5. And we know that y is 5 to the power of x. So from here we know that 5 to the power of x equals to 2 over 5. And another y value will give us another solution of x. Then we have 5 to the power of x equals to 1. So you can see 5 to the power of x equal to 2 over 5 cannot be expressed as the same base. Then in this situation, we will need to use logarithm. So this index form, I will change to a logarithm form, where we have logarithm base 5, 2 over 5 equals to x. So you can just key in this in the calculator and you will have negative 0.569. And as for the other solutions, 5 to the power of x equals to 1, everybody should know that x power 0 always gives us 1. Anything to the power 0 is 1. So we have 5 to the power of x equals to 5 to the power 0. So we have x equals to 0. So you can see that we have a very different way to solve this equation in example 2. So in conclusions, when you have equations that involve additions and subtractions of indices, where we cannot combine these indices, instead of combining them, we have to break down the power. We have to break down this power and use substitutions. Whereas if you look at equations that I show you in example 1, we have multiplications and divisions where we can combine these indices when they have the same base. So after combining them, we will put them in single index and compare their power. So this is the idea of solving exponential equations. I hope this example give you a new insight of the solutions to exponential equations. If you like this video, you may share with your friends. If you guys have any equations that you have problem with, you may leave your comment down below. I will consider making a video to solve your equations. So thanks for watching. See you next time.